Alright, welcome back. Now, we're going to be looking at some recurring decimals now. So let's solve these in exactly the same way as we've solved the other ones. So we're converting from a fraction to a recurring decimal. Right, so we have 1 over 3, so let's express this as a division problem. 3 into 1. So 3 into 1 does not go. And then we can do 3 into 10, and that will go 3 times with the remainder 1. 3 into 10 goes 3 times with the remainder 1. 3 into 10 goes 3 times, and so on. And that will continue going on forever. So this is 0.3333, however many you would like to write. So just because we don't want to write this out every single time, we use a kind of shorthand where we would write 0.3 with a dot on top, and the dot means that this continues. This is a recurring decimal. Alright, let's look at B. We have 2 over 9, so let's convert it to a division problem. Alright, so 9 into 2 obviously does not go, and 9 into 20, well, that goes twice with a remainder 2. And then twice with a remainder 2, and then twice with a remainder, and you can kind of see where this is going to go. So we would write this as 0.2 with a dot on the top to indicate that it is repeating. Alright, let's look at C. So for C we have 3 and 2 sevenths. So the first thing I'm going to do is convert this from a mixed number to a improper fraction. So the way we do this, we would do 3 times 7, which is 21, and then we just add on what the numerator value is. So it's 21 plus 2 over 7, which is 23 over 7. Now we just need to put this into a division problem. So we have 7, and that goes into 23. Alright. How many times does 7 go into 23? Well, it goes in there 3 times, and it has a remainder of 2. So 7 into 20 goes twice with a remainder of 6. And then 7 into 60 goes 8 times with a remainder of 4. 7 into 40 goes 5 times with a remainder of 5. 7 into 50 goes 7 times with a remainder of 1. 7 into 10 goes once with a remainder of 3. 7 into 30 goes 4 times with a remainder of 2. And then 7 into 20 again goes twice with a remainder of 6. And we've started to repeat. So the second we get to a point like here, where we've gone back to our original values, we're repeating, and we need to write this down as our recurring decimal. So this is going to be equal to 3.285714, and this is where we started to repeat. Now, in order to indicate that this sequence repeats itself, we can do two things. We can put a dot on where it begins and ends, or you can write it with a line on top. Alright, I usually prefer the line, but either one works. Alright, here's a few for you guys to practice, so give the video a pause, give them a go, and then I'll solve them. Alright, let's get going. So for D, we have 5 out of 6. So convert it to a division problem. Okay, how many times does 6 go into 5? Well, it doesn't. How many times does 6 go into 50? It goes into 58 times with a remainder of 2. How many times does 6 go into 20? Well, it goes in there 3 times with a remainder of 2, and then 3 times with a remainder of 2, and so on. So this is going to be 0.83, and we just put the dot on the recurring value, which is the 3 and not the 8. Alright, now we have 1 and 1/6. Let's just quickly write this as an improper fraction. So this will be equal to 6 plus 1 over 6, which is just equal to 7 over 6. Now we can write this as a division problem. 6 goes out the front, 7 goes underneath, 6 into 7 does go once. And there's a remainder of 1. And then 6 into 10 goes once with a remainder of 4. And 6 into 40 goes 6 times with a remainder of 4, and then 6 times with a remainder of 4, and we've gotten to the point where we're recurring. So now we will write that the answer is 1.16 with a dot on top of the 6 to indicate that that is the recurring value. Alright, for f we have 1 over 11. So let's put the 11 out the front and put it into 1. So 11 into 1 doesn't go. What about 11 into 10? It's still nothing. What about 11 into 100? Well, that goes 9 times with a remainder of 1. 11 into 10 doesn't go. 11 into 100 goes 9 times, and we can see where this is going. So this is going to be equal to 0.09. And we just want to recognize that the 0 and the 9 are going to recur. Okay, so that, or you can write it as 0.09 with a dot on each one. Alright, that's it for this video. Hopefully it was helpful, and I will see you in the next one.